Okay, let's talk about integer data types. Now I wanted to mention that integers ask the question how many, and floats ask the question how much. So in the integer data type, we're actually looking for whole numbers. When you say how many, you're never looking for a decimal. Integers store, the integer data type itself, int, stores an integer, a whole number, from negative 2,147,482,648 to positive 2,147,483,647. There are variations of the integer type. There's byte, short, and long. The byte is 1 byte. So how many ints can you carry in 1 byte? Well, it goes up to 255, and I'll show that to you here, but in a little bit. But shorts are shorter than that, and long is longer than that. And I'll show you what that looks like here. And you just got to choose the appropriate type, like how much memory do you have? What are you doing? And it looks like this. So a byte, the minimum value is 128. And I think I said 255 before because I wasn't thinking about the size of the byte. So the byte has 255 total, and therefore it has 127 on the positive and negative 128 on the negative. So we use bytes for things like color combinations, like RGB. A short has 2 bytes. So if I could, I don't know if I can quickly draw this out, but effectively 1 byte is, let me bring up a calculator so you can see this. 1 byte is 2 to the power of 8, because you have 8 switches, right? So 2 to the power of 8, and let's see, 2 to the power of 8, and you get this value here, 256. And so, including 0, you have 255 other digits you can handle. When you have 2 bytes, you have 2 to the power of 16. So you can see this here, 2 to the power of 16, 65, 536. This is because, and you can see this on the negative and the positive, including 0, you end up with 65, 536. An integer has 4 bytes. So you're talking about 2 to the power of 64. So we're gonna, oops, let's clear this. So 2 to the power of 64, and you get the wrong value. That value is actually long. The int is actually 2 to the power of 32. So let's look at that again. So 2 to the power of 32. And you get the value here, which is, that's that 4,294,967,296. So effectively, when we increase the number of bytes, we have a massive increase in the amount of values we can add to that. Just like on the single bit side, 1 bit gives you 0 and 1. 2 bytes you can count all the way to 4. So it's exponentially increasing as you step down the integer trail. One thing I want to mention to you is that on integer style data types, you can run the risk of an overflow error. And what an overflow error does is a logic error. Basically, it wraps around. It wraps around to the other side. So if I was to say like byte A equals 8, and then let's pick another value, let's say 3. And then we're going to, while A is greater than 0, I want to print A times A. Let me see, let me do it this way. Print A times equals A. I think this will reassign A to that value. We'll just kind of run it and see what happens. So what I'm expecting to do is reassign the value to A, and then it's going to print out that reassigned value. So I should get 9 and then 81 and so forth and so on. So I'm going to run this program, and you can see I got, let me print line this. All right, I'm going to run this program, and you can see that we get 9, 81, and negative 95. So what happened is 81 times 81, we showed you in a calculator, 81 times 81 is 6,561. So it literally wraps around the bytes many times and returns back to the negative side. If I was to make this a long, let's just make a equal 9. We're going to run this, and you can see it does the same thing. It wraps around, and it comes to this negative value. Same thing with short and int. Here's the short, wraps around to the negative side, and then here is int, and it's also going to wrap around to the negative side. Well, this is important, because if you have some big value, you can potentially return a negative value and really influence your program. So be aware that these integer values do wrap around to the other side. So when you get to 2,147,647, I'll just do that real quick. I'll bring in this particular value here, and I'll bring it into our language and say this. Hold on. Int a equals that value, right, plus 1, right? And then we're going to print a, right? So what you'll see here, just to verify this, you'll see that negative value. So it's important that we know what's happening, right? That we know what's happening, and that we return the correct values based on the overflow. All right, thank you.